Hello, welcome to my YouTube channel, The Curious Mind. Don't forget to like, comment, share and subscribe. CBSE NCERT Class 10 Science Notes Chapter 2 Acids, Bases and Salts. Introduction to Acids, Bases and Salts. A substance that tastes sour in water, turns blue litmus red, and neutralizes the bases is known as an acid. If a substance's aqueous solution tastes bitter, turns red litmus blue, or neutralizes acids, it's called a base. Bases are commonly found in household cleansers that are used to remove oil from windows and floors, as well as soaps, toothpaste, egg whites, dishwashing liquids, and household ammonia. Salt is a neutral material that has no effect on litmus in an aqueous solution. A salt is formed when hydrogen ions are replaced by a metal or an ammonium ion in an acid. A base is a material that reacts with an acid to produce just water and salt. When an acid reacts with a base, it produces a salt. Classification of matter. On the basis of composition. Elements, compounds and mixtures. On the basis of state. Solids, liquids and gases. On the basis of solubility. Suspensions, colloids and solutions. Types of mixtures, homogeneous and heterogeneous. Types of compounds, covalent and ionic. Ionizable and non-ionizable compounds. An ionizable compound, when dissolved in water or in its molten state, dissociates into ions almost entirely. Examples: sodium chloride, hydrochloric acid, potassium hydroxide, etc. A non-ionizable compound does not dissociate into ions when dissolved in water or in its molten state. Examples: glucose, acetone, etc. What is an acid and a base? Acids and bases. An acid is any hydrogen-containing substance that is capable of donating a proton, hydrogen ion, to another substance. A base is a molecule or ion able to accept a hydrogen ion from an acid. Acidic substances are usually identified by their sour taste. Arrhenius, theory of acids and bases. Arrhenius acid, when dissolved in water, dissociates to give hydrogen ion or hydronium ion. Arrhenius base, when dissolved in water, dissociates to give hydroxide ion. Examples: acids, hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. Bases: sodium hydroxide NaOH, potassium hydroxide KOH, calcium hydroxide CaO2. Bronsted-Lowry theory. A Bronsted acid is an hydrogen ion donor. A Bronsted base is an hydrogen ion acceptor. Example: in the reaction, hydrochloric acid Bronsted acid and chloride ion, its conjugate base. Ammonia Bronsted base and ammonium ion, its conjugate acid. Physical test. Given are two possible physical tests to identify an acid or a base. A. Taste. An acid tastes sour, whereas a base tastes bitter. The method of taste is not advised, as an acid or a base could be contaminated or corrosive. Example: the flavors of curd, lemon juice, orange juice, and vinegar are all sour. Because they contain acids, these compounds have a sour flavor. Baking soda has a sour flavor. It's an example of a foundation. B. Effect on indicators by acids and bases. An indicator is a chemical substance which shows a change in its physical properties, mainly color or odor, when brought in contact with an acid or a base. Below mentioned are commonly used indicators and the different colors they exhibit. A. Litmus. In a neutral solution, purple. In an acidic solution, red. In a basic solution, blue. Litmus is also available as strips of paper in two variants, red litmus and blue litmus. An acid turns a moist blue litmus paper to red. A base turns a moist red litmus paper to blue. B. Methyl orange. In a neutral solution, orange. In an acidic solution, red. In a basic solution, yellow. C. Phenolphthalein. In a neutral solution, colorless. In an acidic solution, remains colorless. In a basic solution, pink. Acid-base reactions. A neutralization reaction occurs when an acid reacts with a base. Salt and water are the end products of this reaction. An acid-base neutralization reaction is formulated as a double replacement reaction in this standard approach. Reactions of acids and bases. A. Reaction of acids and bases with metals. Acids, in general, react with metals to produce salt and hydrogen gas. Bases, in general, do not react with metals and do not produce hydrogen gas. A more reactive metal displaces the less reactive metal from its base. B. Reaction of acids with metal carbonates and bicarbonates. Acids produce carbon dioxide, as well as metal salts and water, when they react with metal carbonates or metal bicarbonates. Sodium chloride, carbon dioxide, and water are formed when sodium carbonate interacts with hydrochloric acid. Allowing carbon dioxide gas to travel through lime water turns it milky. Acid plus metal carbonate or bicarbonate, right pointing arrow, salt plus water plus carbon dioxide. Effervescence indicates the liberation of CO2 gas. C. Reaction of acid with base. 1. Reaction of metal oxides and hydroxides with acids. Metal oxides or metal hydroxides are basic in nature. Acid plus base, right pointing arrow, salt plus water plus heat. 2. Reaction of non-metal oxides with bases. Non-metal oxides are acidic in nature. Base plus non-metal oxide, right pointing arrow, salt plus water plus heat. 3. Reaction of acids and base. A very common acid is hydrochloric acid. The reaction between strong acid, says hydrochloric acid, and strong base, say sodium hydroxide, forms salt and water. The complete chemical equation is shown below. Acids and bases in water. When added to water, acids and bases dissociate into their respective ions and help in conducting electricity. Difference between a base and an alkali. Base. Bases undergo a neutralization reaction with acids. They are comprised of metal oxides, metal hydroxides, metal carbonates and metal bicarbonates. Most of them are insoluble in water. Alkali. An alkali is an aqueous solution of a base, mainly metallic hydroxides. It dissolves in water and dissociates to give hydroxide ion. All alkalis are bases, but not all bases are alkalis. Hydronium ion. Hydronium ion is formed when a hydrogen ion accepts a lone pair of electrons from the oxygen atom of a water molecule, forming a coordinate covalent bond. Dilution. Dilution is the process of reducing the concentration of a solution by adding more solvent, usually water, to it. It is a highly exothermic process. To dilute acid, the acid must be added to water and not the other way round. Strength of acids and bases. Strong acid or base. When all molecules of a given amount of an acid or a base dissociate completely in water to furnish their respective ions, hydrogen ion for acid and hydroxide ion for base. Weak acid or base. When only a few of the molecules of a given amount of an acid or a base dissociate in water to furnish their respective ions, hydrogen ion for acid and hydroxide ion for base. Dilute acid. Contains less number of hydrogen ions per unit volume. Concentrated acid. Contains more number of hydrogen ions per unit volume. Dilute base. Contains less number of hydroxide ions per unit volume. Concentrated base. Contains more number of hydroxide ions per unit volume. Universal indicator. A universal indicator has a pH range from 0 to 14 that indicates the acidity or alkalinity of a solution. A neutral solution has pH equals 7. pH equals minus log 10 H plus. In pure water, H plus equals O minus equals 10 minus 7 moles per liter. Hence, the pH of pure water is 7. The pH scale ranges from 0 to 14. If pH less than 7 then acidic solution. If pH more than 7 then basic solution. Importance of pH in everyday life. 1. pH sensitivity of plants and animals. Plants and animals are sensitive to pH. Crucial life processes such as digestion of food, functions of enzymes and hormones happen at a certain pH value. 2. pH of a soil. The pH of a soil optimal for the growth of plants or crops is 6.5 to 7.0. 3. pH in the digestive system. The process of digestion happens at a specific pH in our stomach which is 1.5 to 4. The pH of the interaction of enzymes, while food is being digested, is influenced by HCl in our stomach. 4. pH in tooth decay. Tooth decay happens when the teeth are exposed to an acidic environment of pH 5.5 and below. 5. pH of self-defense by animals and plants. Acidic substances are used by animals and plants as a self-defense mechanism. For example, bee and plants like nettle secrete a highly acidic substance for self-defense. These secreted acidic substances have a specific pH. Manufacture of acids and bases. 8. Non-metal oxide plus water right pointing arrow acid. Non-metal oxides are thus referred to as acid anhydrides. B. Hydrogen plus halogen right pointing arrow acid. C. Metallic salt plus conch. Sulfuric acid right pointing arrow salt plus more volatile acid. D. Metal plus oxygen right pointing arrow metallic oxide base. E. Metal plus water right pointing arrow base or alkali plus hydrogen. F. Few metallic oxides plus water right pointing arrow alkali. G. Ammonia plus water right pointing arrow ammonium hydroxide. Salts. Salt is a combination of an anion of an acid and a cation of a base. Salts are usually prepared by the neutralization reaction of an acid and a base. Common salt. Sodium chloride NaCl is referred to as common salt because it's used all over the world for cooking. Family of salts. Salts having the same cation or anion belong to the same family. pH of salts. A salt of a strong acid and a strong base will be neutral in nature. pH equals 7 approximately. A salt of a weak acid and a strong base will be basic in nature. pH greater than 7. A salt of a strong acid and a weak base will be acidic in nature. pH less than 7. The pH of a salt of a weak acid and a weak base is determined by conducting a pH test. Chemicals from common salt. Sodium chloride is a common salt. NaCl is its molecular formula. The fundamental element in our meals is sodium chloride. It is used in our food as a flavor enhancer as well as a preservative. From common salt, we may make the following 4 compounds. Sodium hydroxide or lye or caustic soda. Baking soda or sodium hydrogen carbonate, or sodium bicarbonate. Washing soda or sodium carbonate decahydrate. Bleaching powder or calcium hypochlorite. Preparation of sodium hydroxide. The strong base sodium hydroxide is a common and useful one. Preparing a solution of sodium hydroxide NaOH in water requires extra caution because the exothermic reaction releases a lot of heat. It's possible that the solution will spatter or boil. Here's how to manufacture a sodium hydroxide solution safely, as well as recipes for a variety of NaOH strengths. Chemical formula: NaOH, also known as caustic soda. Preparation: chlor-alkali process. Electrolysis of brine solution of common salt, NaCl, is carried out. At anode, Cl2 is released. At cathode, H2 is released. Sodium hydroxide remains in the solution. Bleaching powder. Bleaching powder is soluble in water and is used as a bleaching agent in textile industries. It is also used as an oxidizing agent and a disinfectant in many industries. It should also be noted that bleaching powder is synthesized by the reacting chlorine gas on dry slaked lime, i.e. On interaction with water, bleaching powder releases chlorine, which is responsible for bleaching action. Uses of bleaching powder. It is used for bleaching dirty clothes in the laundry, as a bleaching agent for cotton and linen in the textile industry. It is a strong oxidizing agent, hence used as an oxidizer in many industries. It is used as a disinfectant, which is used for disinfecting water to make potable water. Baking soda. Sodium bicarbonate, also known as baking soda or bicarbonate of soda, is a chemical compound with the formula NaHCO3 and the IUPAC designation sodium hydrogen carbonate. A sodium cation Na+, and a bicarbonate anion HCO3 combine to form this salt. Sodium bicarbonate is a white, crystalline substance that is commonly found as a fine powder. It tastes slightly salty and alkaline, like washing soda, sodium carbonate. Chemical name: sodium hydrogen carbonate. Chemical formula: NaHCO3. Preparation: Solvay process. A. Limestone is heated. B. CO2 is passed through a concentrated solution of sodium chloride and ammonia. Uses: reduces the acidity in the stomach. Acts as an antacid which is used to treat stomach upset and indigestion. Used in the process of washing as a water softener. Washing soda. Chemical name: sodium hydrogen carbonate. Chemical formula: NaHCO3. Preparation: Solvay process. A. Limestone is heated. B. CO2 is passed through a concentrated solution of sodium chloride and ammonia. Uses: 1. In the glass, soap and paper industries. 2. Softening of water. 3. Domestic, cleaner. Crystals of salts. Certain salts form crystals by combining with a definite proportion of water. The water that combines with the salt is called water of crystallization. The process by which a solid form, in which the atoms or molecules are strongly arranged into a structure known as a crystal, is known as crystallization. Precipitation from a solution, freezing, and, more rarely, direct deposition from a gas are some of the ways crystals form. Example: table salt, sodium chloride or halite crystals, sugar, sucrose, and snowflakes are examples of common materials that form crystals. Many gemstones, such as quartz and diamond, are crystals. Plaster of Paris. Plaster of Paris is a widely used chemical compound that is extensively used in sculpting materials and gauze bandages. Plaster of Paris is a white powdery chemical compound that is hydrated calcium sulfate that is usually obtained by calcining gypsum. While we have seen many applications of this material in our everyday lives, if we try to understand its chemistry, we will find that it is a white powdery chemical compound that is hydrated calcium sulfate that is usually obtained by calcining gypsum. To put it another way, plaster of Paris is often manufactured of heated gypsum at a high temperature. Gypsum plaster is another name for the plaster of Paris. Plaster of Paris is expressed as gypsum, on heating at 100 degrees Celsius 373 K give plaster of Paris. CaSO4, 1/2 H2O means 2 formula units of CaSO4 share 1 molecule of water. Uses: cast for healing fractures. Frequently asked questions on acids, bases and salts. Q1. When dissolved in water, areneous base is a compound that. An areneous base is a compound that increases the concentration of OH ions that are present when added to water. Q2. Solution X has a pH value of 2, and another solution, Y, has a pH value of 1. What can be inferred regarding the difference in hydrogen ion concentration between them? pH is a measure of hydrogen ion concentration in a solution. The higher the hydrogen ion concentration, the lower the pH. Acids which give rise to more hydrogen ions are more acidic than acids which give fewer hydrogen ions. Thus, the lower the pH, the higher the acidic nature of the solution. Thus, Y has more hydrogen ion concentration than X. Q3. Dilute hydrochloric acid HCl reacts with metals to evolve or gas along with the formation of corresponding metal salt. Acids react with metals to produce the respective metal salt along with hydrogen gas. Therefore, when hydrochloric acid HCl reacts with metals, it evolves hydrogen gas along with the formation of corresponding metal salt.
If you find this video helpful, give it a thumbs up and share it with your friends. For more videos like this, hit the subscribe button and remember to click on the notification bell. Also be sure to check out our other videos as well. Thank you for watching.